discussing about the armature windings of the synchronous machine. The topics to be covered are various winding schemes, important terminology, and preferred configuration of the armature windings in synchronous machines. So, we'll start with the armature winding schemes. First of all, what are the armature windings? So, the stationary part of the large synchronous machines is the armature. On the inner periphery of the stator core, the number of slots are provided, and in these slots armature windings are placed. Various winding schemes can be adopted to wound the armature of an alternator. It can be single phase and polyphase windings, concentrated and distributed windings, single layer or double layer windings, full pitch or short pitch windings, or concentric or lap or wave windings. So we'll try to understand one by one each type of winding. When only one winding is placed on the armature and only one EMF is obtained at the output of the winding, it is called single phase winding. This is the representation of single phase winding, a single coil that is placed in the armature. When more than one windings are placed on the armature, the EMFs induced are more than one, displaced each other by some angle. The winding is called the polyphase winding. For example, you can see a two-phase winding which are displaced by 90 degrees from each other. Mostly three-phase winding is provided on the armature, and you can see the three-phase winding. The advantage of the three-phase winding is the equal distribution of the winding throughout the periphery of the armature. Concentrated and distributed windings. So when one slot per pole or slots equal to the number of poles are employed, the windings thus obtained are called the concentrated windings. Such windings give maximum induced EMFs for a given number of conductors, but the waveform of the induced EMF is not exactly sinusoidal. So here is an example of a salient pole machine where the poles are being wounded by the concentrated winding. When number of slots per poles are more than one, the windings thus obtained are called the distributed windings. Such windings give slightly less than the maximum induced EMF for a given number of conductors, but the waveform of induced EMF is more or less sinusoidal. So this is a scheme of the distributed winding where the winding is distributed throughout the periphery of the given stator. Single and double layer windings. When only one coil side is placed in one slot, the winding is called a single layer winding. You can see only one coil is placed in one slot. When two coil sides are placed in one slot, one over the other, the winding is called a double layer winding. So you can see in the same slot we have got two coil sides being placed over here. Full pitched and short pitched windings. When two coil sides of the same coil are 180 degrees electrical apart, the winding is called the full pitch winding. So over here you can see the electrical degrees are complete from 1 to 7. So if the coil sides are in 1 and 7, then the complete electrical 180 degrees is covered, and therefore this is known as a full pitch coil. When two coil sides of the same coil are less than 180 degrees apart, the winding is called as a short pitch coil. Like over here, the dotted line shows the short pitch coil, which is just a slot ahead of the full pitch coil. The EMF induced in each coil is maximum with full pitch winding scheme is employed, whereas EMF induced in the short pitch winding is less than that. The short pitch windings is preferred over the full pitch winding because of the following reasons. It decreases the length at the end connections and thus amount of copper required is saved. It reduces the slot reactance and thus improves the wave shape of the generated EMF. That is, the generated EMF can be made to approximately sinusoidal more easily by properly cording the windings. Due to elimination of high frequency harmonics, eddy current and hysteresis losses are reduced, thereby increasing the efficiency of the given machine. The only disadvantage of short pitch winding is that a few more turns are used to obtain the same voltage as it would be induced in a full pitch winding. The next comes the concentric, lap and the wire windings. When each group of coils under a pole is arranged into a sort of concentric shape, that is, when the current flow is traced through one such properly connected set of coils, that the conductors seem to form a spiral around a portion of the core, the winding is called as a concentric or chain or spiral winding. It looks like a spring spiral. This type of winding scheme is preferred for large diameter, low speed synchronous machines. Now over here you can see one spiral is being formed from first to 6, then 2 to 5 and 3 to 4. So that acts like a complete spiral winding. Similarly, the other set of poles are being found by the other spiral set of windings, that is from 7 to 12, from 12 to 8, 8 to 11, 11 to 9 and 9 to 10. So this is a spiral winding. Next comes the lap and the wave winding. In alternators, lap and wave windings give the same EMF as long as the other conditions are same. Lap winding coils or coincides overlap the other consecutively and connections are made. In wave winding, the coils are always forward connected. The connections of a lap winding are simpler to that of a wave winding. Therefore, lap winding is exclusively being used. Now over here you can see a lap winding where the coil is placed from 1 to 4, then 2 to 5, then 3 to 6. This means it is progressing. And similarly, the next winding you can see from 7 to 10, then 8 to 11, then 9 to 12. So it's not a spring, but it is progressing one after the other. While in the wave winding, it doesn't come back. If the wire is from 1 to 4, then it will go from 4 to 7, then 7 to 10. So it completes the complete periphery of the stator winding, and then it comes back to its original position. Then only it will be going one ahead. Else it will continue circulating across the periphery with the same type of the consecutive structures. So the wave winding is just looks like a wave because it progresses and it doesn't come back. So it looks like a wave shape, hence the name is given as the wave winding. While in the lap winding, it is just overlapping each other, hence the name is given as the lap. Now the important terminologies what we use for the armature windings. Electrical angle. When a conductor passes through a pair of poles, one cycle of EMF is induced in it. Thus, a pair of poles represents an angle of 360 electrical degrees. There is perfect relationship between the electrical and the mechanical angle. While mechanical angle is one complete rotation, the electrical angle is one pair of poles completion. So, electrical angle is equal to mechanical pole into the pair of poles. Pole pitch. Distance between two neutral axes or similar points of adjacent poles is called the pole pitch. The pole pitch can be expressed as number of slots per pole or electrical degrees. If S is the number of slots on the whole periphery of armature and P is the number of poles, then the pole pitch is number of slots per pole is equal to S by P. Suppose you have got number of slots as 24 and number of poles as 4. So 24 divided by 4, there will be 6 slots which will make a pole pitch. Coil. Two conductors placed in two slots displaced by a pole pitch or less than pole pitch connected at one side by the end connections of a single turn coil. When number of turns are connected in series and each coil is placed in the same slot, then it is called as a multi-turn coil. So it can be represented in different ways. Either it can be single turn, then just a simple coil will be represented as the A part. Second one, it is a multi-turn coil. So it can be placed in the same slot, one over the other. Then you can make a bunch of wires and you can tape it together and that will form as another coil. While the other coil, what in the D it has been shown by a single line diagram and the two ends shows its end connections. The coil pitch or the coil span. The distance between two active sides of a coil is called a coil span. It is expressed in terms of the number of slots or electrical degrees. So, when the coil is going from one to the next part, that is in the seventh part, then that will be the pole pitch. What is a slot pitch? The distance between the center points of two consecutive slots or teeth is called the slot pitch. So, it is expressed in electrical degrees and slot pitch is equal to alpha 180 degree divided by number of slots per pole. So as we have defined before, we had got the number of slots per pole as 6. So alpha will be 180 divided by 6, that is 30 degrees. Phase spread, the angle or space of pole face over which coil sides of the same phase are spread is called the phase spread. In a distributed winding, the conductors of one phase under one pole are spread in number of slots so that each phase has equal distribution. In a three-phase winding, phase spread is 60 degrees, that is 180 divided by 3 will be 60, and phase spread is given by number of slots per pole per phase. So preferred configuration of armature winding, that is what exactly is preferred practically. Synchronous machine armature windings are always of non-salient pole type and are usually symmetrically distributed in slots around the complete circumference of the armature. The rotor may be salient or non-salient pole type, but the armature is always non-salient pole type. These are generally open circuit type. Both ends are brought out and a closed circuit will be formed only after the external connections is made through a source or the load. They are symmetrically distributed in slots around the complete circumference of the armature, and the distributed winding has got two principal advantages. It generates a voltage wave that is almost a sine wave. Copper is evenly distributed on the armature surface, and heating is more uniform and can be more easily cooled. It may use full pitch coil or fractional pitch coils, although EMF induced in a fractional pitch coil is less than that of a full pitch coil, but fractional pitch coils are preferred for two main reasons. Less copper is required per coil and the waveform of the generated voltage is improved. Normally we use the double layer armature winding arrangement, which permits simpler end connections and is economical. For a three-phase machine, the three windings of the three phases are identical but is spaced 120 electrical degrees apart. Three-phase windings are always designed for 60 degrees phase spread. So today we have studied about the different winding schemes, that what are the different types of winding available for the armature winding, important terminologies, and the preferred configuration for the armature winding of a synchronous machine. Thank you.